Welcome back to NACAA 2022. We hope you're enjoying today's stream. Our first presentation for the current stream is going to be on the 1922 Total Solar Eclipse, proof of Einstein's theory of general relativity in Australia. In 1922, amateur and professional astronomers flocked to observing sites on both sides of Australia to observe a spectacular total solar eclipse. In this illustrated presentation, Dr. Tona Stevenson will explain how and by who Einstein's theory of general relativity was indisputably proven. Dr. Stevenson is a committee member and past president of Sydney City Skywatchers. She's an honorary affiliate in the History Department of the University of Sydney and manager of the School of Humanities. She has 35 years experience in museums and heritage, including 12 years as manager of Sydney Observatory. She researches women in astronomy and has experienced 6 total solar eclipses. Welcome to the stream, Tona. How are you going today?
Thank you very much, Mark. I'm going very well. And before I start, I'd like to pay respects to the Garigal and Guringai people whose land I'm coming from today, land never ceded, and to pay respects to them as the first astronomers. And the knowledge holders of land, sea and sky. I've really enjoyed this conference so far, and on the first day, I heard Dr. Sarah Webb speak about the big questions in astronomy today. And general relativity was really one of the biggest questions in astronomy over the last 100 years. And its proof changed our complete understanding of the cosmos. And that's what I'm going to speak about today. So, what is general relativity all about? Proving the theory, which was first published by Albert Einstein in 1915 and then described in mathematical detail in 1916, was incredibly important. However, it wasn't easy to prove. And one of the ways that you could prove this theory was during a total solar eclipse. Now, I've tried to put together a diagram to explain this, and my diagram's actually from A.D. Ross, who was part of that experiment in 1922, to show that when you're not in eclipse, the red line and star A, that's red star A, they're both the same stars, star red A and green A, that when you're not, when star A is not being viewed near a big massive object like the sun, it looks to be in a certain position. But when it's really in that same position, but you have a massive object like the sun, the light from star A will actually be deflected by the sun's gravity. Now, and you can see that during a total solar eclipse. So you can see here there's a spot on Earth that's during totality. There's the moon blocking out the sun, which makes it possible when we're talking about 100 years ago to take images. And then you see the 2 stars and the difference in where they would appear on a photographic picture was 1 minute and 75 seconds of arc. So starting with that, you can see it was possible to actually prove this theory, which seemed quite difficult given that it involved 4 dimensions. The fourth of those dimensions was, of course, time. Now, the essence of general relativity is that the curvature of space is due to these large, massive objects, which cause a distortion in space-time. And it was really a consequence of the theory that the light rays passing close to a massive object like the sun would be deflected by this quite small but yet measurable amount. And there were attempts made in 1918 when the First World War was still really in the throes of that war. And this attempt was made in North America but the findings failed to prove the theory. So 1919 came along. Now, remember, the war was still on. It hadn't finished. The treaty had not been signed when this eclipse happened. But the British were determined to prove this theory one way or the other. And they formed a special committee whose members included Arthur Eddington and Astronomer Royal Frank Dyson. And they prepared 2 expeditions, one for Brazil and one for West Africa. And the setup in this image here shows what was happening in Brazil. And you can see they were using the 33 centimetre astrograph. That had been part of the astrographic catalogue project. And they also used a smaller telescope, a 10 centimetre telescope. You can also see in this image the coelostats. And that meant that the telescopes did not have to move, but the coelostats actually tracked what they were trying to image. So they tracked the eclipsing sun. Now, everything seemed to be going well, particularly in Brazil, where they had good weather for this eclipse. However, and they had big ambitions. They wanted to take at least 12 stars to prove this theory. And they took 27 photographic plates in total. However, when the photographic plates were developed and compared with the photographic plates that they'd taken of those same stars at a different time, and they did this later in this case, so they had the eclipse, they took the images of the eclipse, then they went back 3 months later, used the same instruments, same location, re-photographed the sky with those stars, exactly the same stars. When they did the comparison, they found that the images that they'd taken during the eclipse were not that good. In fact, the astrograph images were quite fuzzy, and they said that was because of the coelostat didn't work as well as they'd hoped. However, the 10 centimetre telescope images, they were okay. In West Africa, however, they had a lot more problems with their humidity. They did come up with some reasonable images there, again using an astrograph. And there was a paper presented to the Royal Society in November in 1919, 6th of November. And Dyson said the greatest weight must be attached to those images obtained with the 4-inch or 10 centimetre lens at Sobral. He actually announced that after a careful study of the plates, he was prepared to say that they confirmed Einstein's theory, indisputably. Now, that's not what all the other scientists thought, and even Eddington was not convinced that they had done the job. And you can see on this slide that there were great differences in their mean results of the stars, that deflection between the images of the stars. And you can see they actually got quite close to Einstein's theory, at least in West Africa with the astrograph and with the 10 centimetre in Brazil. But it was not good enough because of this difference. The next perfect eclipse was in Australia. And you can see on this list, it attracted great attention. Astronomers from all around the world were keen to come and have a go. And there were astronomers from Britain on Christmas Island, other places where the eclipse went through. But Australia had the best opportunity because of the weather, and at least in Western Australia, at Wallal Downs, the sheep station, the sun would still be 30 degrees above the western horizon at totality. And as the eclipse went across Australia, that decreased remarkably, and so did the time of totality. So in Wallal, the totality was 5 minutes and 20 seconds. And I would love to see an eclipse for 5 minutes and 20 seconds. But that time reduced substantially as you went across the country. So over in Gundawindi and Stanthorpe, it was a little over 3 minutes. And in this presentation, I'm actually going to concentrate on Wallal, which was in this quite remote area of Western Australia. And however, I will quickly touch on some of the other locations before I go there. So Cordillo Downs, now that's up in the north of South Australia, almost where South Australia, Northern Territory and Queensland meet, and on a remarkably remote station called Cordillo Downs, Adelaide Observatory, led by George Dodwell, went, and he established an impressive site. You can see this amazing coronagraph, which is 40 foot or around 12 metres. This was exactly the same as what they were using in Wallal. Now, they, of course, couldn't move this coronagraph. They had to use a coelostat with it. However, the Einstein camera that they were using here was able to track. It wasn't the same as the ones at Wallal, which I'll go into in a little while. This is a photograph from an amazing album by Alexander Lorimer Kennedy, who was the assistant astronomer at Adelaide Observatory. And there are many amazing photographs in that album. In Gundawindi, Sydney Observatory established a site. They took the astrograph, and this was under the direction of Frank Dyson, because they wanted those comparisons. They'd already used two astrographs, remember, back in West Africa and in Brazil, and they wanted to use an astrograph in Australia, and Sydney Observatory was charged with assembling the astrograph. But you can see from this image that they planned to track the eclipse, not to use a coelostat for this particular instrument, and that's because of Eddington. Eddington said that he thought it would be much better to track the eclipse if you wanted to prove Einstein's theory, because of the you needed to get some quite faint stars, and he felt that that would be a much better methodology with what they had available in the day. The image at the right, Melbourne Observatory, a number of people in this conference today will probably recognise some of the people in this image. Father Piggott is there in the centre. He was from Riverview Observatory. Now, I point him out because he was very influential in assisting the international teams that came over and making sure that they had what they needed in terms of support from the government. In Stanthorpe, a little way from Gundawindi, but still with a really great view to the west because of the hills. They were able to get into high positions. Here we have the BAA New South Wales branch, and that's now Sydney City Skywatchers, which I'm a member of. And you can see Walter Gale, who's probably the best known of them, third from the left. Walter Gale's well known for his astronomical observations. And this too was, a well thought through expedition. Now to Wallal Downs. William Campbell, the director of Lick Observatory in California, and he is the fourth from the left. So he's next to his wife in the spotted white dress, Elizabeth Campbell. He led the expedition, and Wallal was in that Kimberley region off the coast of Western Australia, just south of Broome, mainly accessible by sea, and as well as the longest totality, and that 32 degrees above the horizon, This location also had great opportunities because of the clarity of the atmosphere and the historically low rainfall during September, and little wind was predicted. Campbell and his wife Elizabeth were very experienced eclipse observers and expedition organisers, and they had really detailed knowledge of the problems that the British had experienced in 1919. They also had the help of Eastman Kodak Company and Yale University, and they were funded by a very generous philanthropist called William Crocker. They had new instruments designed and built well before this eclipse. And they also specified glass photographic plates to be very large, 432 millimeters square. They were 6 millimeters thick and each weighed over 3 kilograms. Now, you know that this means that then the plate holders have to be very, very robust, and the whole balance of the instrument particularly impacted by these photographic plates. These were very, very high quality plates, and they weren't really used elsewhere. The images for the stars in comparison were taken earlier this time. They were taken in Tahiti months prior. And so the expedition gathered together in Sydney. The North Americans gathered together in Sydney, and under Lieutenant Commander Quick from the Royal Australian Navy, the expedition travelled by train to Fremantle. They stopped regularly along the way in 6 cities, and when they did, they were treated like celebrities. They met the representatives of the Royal Societies, the astronomers, academics, government officials. There were great dinners, and there was the press. Australia was interested in what was happening, and the name Einstein was commonly said around the streets. The expedition departed Fremantle on the 20th of August, and there was great fanfare, streamers onto the boats when they were leaving. They went on the commercial steamer SS Sharon to Broome. There they unloaded onto whaleboats. It was really heavy surf, very, very treacherous. They transferred the equipment to a twin-masted schooner called the Gwendolen. And there in Broome, they picked up astronomers from India, as well as supplies. Now they had an eclipse party of over 30 people, including 2 filmmakers. And at the end of this talk, I hope we have time, we'll show a little clip from the Sun Worshippers film. But these 2 filmmakers, Ernest Budd, Brandon Kremer, and his assistant, they completely documented this expedition in both cinematography and still photographs. And most of the images that I'm showing you today were taken by them. They also took a lot of images of the 30 Nyangumada men and women, the First Nations people in this area, who were contracted by the Lick Observatory to help the expedition. And they actually, I can't show you some of that. Some of that is actually quite restricted in who can see it. But the still images alone show that these people use their local knowledge to help the eclipse expedition. And Elizabeth Campbell, in her diary, she writes about how they did things like they bought heavier sand and covered the area so that there wouldn't be as much dust. The fresh water was brought by the women. Now, the well was over 500 metres away, and they also used the water to dampen the ground during the eclipse. They prepared local foods, beautiful mussels from the beach were collected, and they really contributed significantly to the whole experience of the expedition and the success of it. Now, this is an image of them arriving at Wallal Downs, and you can see a Nyangumata woman leading the donkeys. The donkeys are carrying the equipment, and it was quite treacherous actually to unload the equipment off the steamer onto these small boats. At low tide, it could be carried and then onto the donkeys, 35 tons of equipment, and then to the site. It was, the whole trip at various stages was fraught with peril. However, they successfully managed this stage. And the eclipse camp was substantial. I particularly like this image of the Cafe Einstein, where they would have meals. They'd escape from the heat. It was very hot. They would also manage to gather, talk, plan. And this sign, Cafe Einstein, has some words underneath it that you can't read, which says, meals open all hours. On the left, you can see another one of these coronagraphs that you saw at Cordillo Downs, a 12-metre high Chabot coronagraph. You can also see one of the filmmakers on the right there. The coronagraph was to take photographs of the images of the corona, but also the partial phases of the eclipse that they wanted to get really high quality images of. There were also these very special Einstein cameras that were, as I said, were taken to Tahiti, and they were specially designed. They had apertures of 127 millimeters and a focal length of 4.57 meters, almost 5 meters. There was another pair with the same focal length and slightly less aperture, and they were to also photograph the stars and the area immediately around the sun. There was a Floyd camera, and this was to photograph the corona, and there were also several spectrographs to record the chemistry of the corona. Toronto University, who were also there, they had a 3.3 metre long camera for the Einstein experiment, quite similar to the other ones and specifically designed. Perth Observatory was also on this site. They were a little away, but they were equipped with a 300 millimetre aperture reflector telescope and 2 small cameras to photograph the corona. While proving Einstein's theory was very important, it wasn't the only science that they were doing. Now, this is the end of one of the Einstein cameras. And these were large cameras, and they took time and patience to align. Everyone was really busy in the days prior to the eclipse. However, the flies were really bad, and you can see in this photograph the netting over their hats. It was quite hard to look through. If you didn't have this netting, you couldn't really be looking through eyepieces. The flies would be getting into your eyes, your nose, your mouth. They all practiced their jobs many times before the Thursday, the 21st of September, the day of the eclipse. William Wallace would shout, "Go!" and they'd take their positions in rehearsal because they knew that they had 10 minutes until the eclipse would occur. They did this many times. And the world was watching. The world was waiting to hear what happened. Aviator Charles Kingsford Smith and aviator Norman Brearley, they brought the mail to Wallal Downs, and they also stayed to view the eclipse, and they flew news back very quickly. Again, this is another amazing part of this expedition. At this stage, Kingsford Smith was a very young pilot, building up his hours of experience for what we know is to come later. And then eclipse day began at 12:02 p.m. And even though the temperature was 34 degrees centigrade, Campbell described the weather as perfect. It was clear. Campbell and Trumpler, his assistant, were aided by the Navy, and they were in charge of the Einstein cameras. Melbourne Observatory astronomer John Benjamin Hosking was also there, and he worked with New Zealand government astronomer Charles Edward Adams, and they were in charge of the wireless and the weather measurements. Alexander Ross from the University of Western Australia, he recorded the positions of the moon's shadow during the partial phases of the eclipse, and he deduced that totality would occur 16 seconds prior to the predicted time. And this was really vital information when you're doing this type of precise experiment. It came just in time to inform the photography schedule. And all the women in the expedition were assigned to instruments. You can see Elizabeth Campbell here. She was photographing the corona during totality using the Floyd camera. Eleanor Adams worked closely with her husband on the large 12-meter coronagraph to photograph those partial phases. She was changing the photographic plates and ensuring the drive mechanisms were accurately tracking. Some exposures were over 1 minute long. Mrs. Jean Chant made observations on the shadow bands, and she also tested the brightness of the sky. As I said, other things were happening that were interesting to record. She also operated 2 small cameras. And the orientation of what's called a Nicole prism was an experiment to polarize light and better understand its nature, and that was carried out by Elizabeth Chant. Perth Observatory were also there, and they were doing really important work with the timekeeping through wireless signals, which the Lick Observatory were not as successful as getting those wireless signals as Perth Observatory. They got their wireless signals from France, actually, and they also did an amazing job with exact location mapping. That was vital information during this experiment. They were led by Clive Nossiter, who was the assistant astronomer of Perth Observatory, but they were a little way away from the others. And this interested me, and I found out more when I read a letter from Nossiter to a colleague. While he regarded and he noted how helpful the Aboriginal people were as labourers and cooks, he did not appreciate the women in the other expedition. And he wrote to this colleague, I may say that our party consists of a very fine lot of men, and that although they understand they have plenty of work ahead of them, they are going with the determination of having a really camp and happy time. I might also say there are ladies with the Lick party, and we are averse to occupying a camp with ladies on an open plain where there is practically no privacy. And this tells me 2 things. It was a different era, and so you expect this. But it also tells me that privacy was an issue, and so you can understand some of that sentiment, of course. But on the other hand, the international expeditions really used the talents and expertise of the women, because those women involved in this had all been to at least one, if not more, eclipse expeditions prior, and they knew what they were doing. After the eclipse, they tried to develop the images. They did develop some, but the atmospheric conditions and the dust made it difficult, and they wanted ideal conditions. They packed very quickly, but the wind and the waves had picked up. And crossing the ocean to the Gwendolen ship was very dangerous. In fact, they lost parts of the Einstein cameras overboard, and this little inset image shows Campbell looking through the irons and setting up one of the Einstein cameras. But luckily, they didn't lose the glass plates. And there's one on the large image here shows the circles. You can't see the stars. Well, I can't anyhow, but I can see the circles which are circling some of the stars they were using for their experiment. However, the sea calmed, the tide receded, and they were able to safely load back onto the Gwendolen and be towed back to Broome. And they developed their photographic plates in Broome. And Campbell did make some preliminary but satisfactory measurements of 80 stars, but he did not publish until the following year because he wanted to be absolutely certain. However, there was success, and he said our observations agree very closely with the Einstein prediction. And the results were from 84 stars. And you can see Einstein's theory was 1 minute 75 seconds deflection. Lick Observatory's result was 1 minute 74 inches of deflection. The mean value was used from those 84 stars. The image on the right, you can see, is from the paper that he published with one of the other astronomers who did the measurement. Was a very experienced measurer and computer. And you can actually see how that looks. And you can see from the lines which show the deflection. This is an image of the eclipse, and you can see the sun in the middle, and then the corona, and then radiating areas of the corona. This sketch shows 92 stars, and not all the stars were used in final calculations, and there were very good reasons for that. So in the end, they actually did what they set out to do. They proved what they wanted to prove, and there was regularity and very little variation. That was what they were looking for. Now, if I've got time, which I think I do, I'll quickly skip to the other side of Australia and a very, very different type of expedition. And this is Miriam Chisholm with her father Frank in their very purpose altered car, setting off. They were setting off from Goulburn with Miriam's friend Frida Tyndall to view the solar eclipse in Gundawindi. They took with them a couple of telescopes and lots of measuring instruments, and they carefully read the meteorologist Hunt's booklet, which gave incredible information about the eclipse. And they were going there to do some amateur science. They almost missed the eclipse because their car, you can see the very thin wheels of the car got bogged, they broke down, they lost 4 days of travel, and they were half an hour away from the eclipse site at Gundawindi. And they were 14 kilometres away from Gundawindi, half an hour before the eclipse was to begin. And so they stopped the car by the roadside and they set up their eclipse camp where they were, which was still in the path of totality. This was a good decision because they had an excellent eclipse, and their instruments worked well because they reported the stars, they reported the planets, they took measurements of the temperature, which dropped from 20 degrees centigrade to 15.5 degrees centigrade. They viewed Mercury, Venus, Saturn, and Jupiter. They drew the corona. However, their photographs didn't turn out that well. Miriam and Frida, as co-author, were some of the very few women to publish a very comprehensive report of the 1922 eclipse. And there were other observations by members of the BAA New South Wales branch, which they joined soon after the eclipse. So in conclusion, the influx of international astronomers, as well as the eclipse itself, and the effort to prove the Einstein effect, raised enormous public interest in astronomy in 1922. A great effort was made to ensure everyone possible, including school children, had information about the eclipse and how best to safely observe it. And Lick Observatory proved beyond doubt, using many stars, the deflection of light caused by the gravity of a massive object in space, and thus that general relativity was no longer a theory. And this opened up new areas of science called cosmology and made possible the existence of phenomena such as black holes. My research for this presentation was for a chapter in the book I'm co-authoring with Professor Nick Long, Associate Professor Dwayne Hummersher, Uncle Gilla Michael Anderson, Melissa Holbert, Kirsten Banks and Jeff Wyatt, and it will be published by CSIRO Publishing and called Eclipse Chasers. And when this book comes out in March 2023, sorry, I can't avoid a plug here, you'll be able to get it to prepare for the future and understand the past. A big thanks to the Astronomical Society of Victoria for allowing me to talk today. And if we have a few minutes, we might go to something else quite exciting. Mark, over to you.
Okay, so we've got a little video that we're going to share. I'll get this going now. There is no audio with this video, so enjoy. There we have it, all finished. It's a wonderful video that was.
Yes, I enjoy it.
Needs some music though, I think. Thank you very much for your presentation today. It was a wonderful talk, and that video at the end was beautiful to see them working on that experiment, and from having seen the slides and having you talk about the what they got up to. Now we're going to say goodbye to Tona, and we're going to bring in Terry Cuttle, who will be giving a talk on looking at the 5 total solar eclipses coming into Australia. This presentation will discuss the unique occurrence of the 5 total solar eclipses that will occur across Australia in the coming period of just 18 years. So it's going to be a busy next few decades. Presented by Terry Cuttle, who is a retired engineer and is known in the amateur astronomy community as an eclipse enthusiast and astrophotographer, and he has given many presentations on these subjects. He's traveled to, observed, and photographed 17 total solar eclipses and has been active in the community education on eclipses, specifically involved in preparing detailed school education material and public safe viewing advice for the 2012 Queensland eclipse, and more recently assisting the American Astronomical Society to prepare the American community for the 2017 USA eclipse. Terry, welcome to the stream.
Right. Okay.
The floor is yours.
Okay. Thanks very much, Mark, and thanks for that introduction. Good morning to everyone who's watching from Australia, and good day to anybody who's watching from anywhere else. Today I want to talk about the remarkable opportunity that we have here in Australia. We will have 5 total solar eclipses coming to Australia over the next 16 and a half years. So what I'd like to talk about is a description of how a solar eclipse occurs and what you can see, a description of each of the 5 eclipses with their paths across the country, how to safely watch an eclipse, some tips on eclipse photography, and then end up talking about the educational opportunities that these eclipses present. So a bit of revision about how a total solar eclipse occurs. It occurs when the moon in its orbit comes between Earth and the sun, and that casts a shadow on the Earth, and that's called the umbra. From a location on Earth within the umbra, the sun is completely hidden, and the amazing spectacle of a total solar eclipse can be seen. From the area around the umbra, the sun is only partially hidden, and a partial solar eclipse can occur. Now, as the moon orbits the Earth and the Earth rotates, the umbra traces out a path across the Earth, and this is called the path of totality. And from within that path, a total solar eclipse will occur. You need to be in that path to experience the total solar eclipse. From the area outside the path, the sun will only be partially covered, and a total solar eclipse and a partial solar eclipse will occur there. So something must be said about this. There is a huge difference between a total solar eclipse and a partial solar eclipse. For a partial solar eclipse, the moon progressively covers the sun, it reaches a maximum coverage and then uncovers the sun. It doesn't include the dramatic total part of the eclipse. Now, a partial eclipse, of course, occurs on either side of the path of totality, where the moon doesn't appear to line up perfectly with the sun. The total solar eclipse starts with the partial phases as the moon progressively covers the sun, and it includes the dramatic total part of the eclipse when the moon completely covers the sun goes very dark, and the sun's corona can be seen, and then it ends with the final partial phases as the moon progressively uncovers the sun. So, what to see and what to image. Here we see the partial phases where the moon progressively covers the sun, and that takes about an hour or an hour and a half. But the real drama is in the last few minutes before totality. At first, it's a slow change in the light level, and then it's very fast. And then the light drops dramatically. You can see the moon's shadow rushing towards us as a dark, ominous cloud, and it gets very dark very quickly. And it can feel quite cold. There's a steely blue light in the sky, and it drops quickly to a deep twilight. The first time you experience this, you get a strange, surreal feeling, unlike anything you've seen before. What's happening? And the transition in the final final seconds before totality, you'll see Bailey's beads. They appear as the last part of the sun shines through the valleys around the edge of the moon. When the light gets down to one point, it looks like a gorgeous diamond ring. When the diamond ring disappears and the sun's surface, that's the bright photosphere, is completely covered, in the first few seconds of totality, you can see the bright crimson arc of the chromosphere, and that's the sun's lower atmosphere. And you can see pink prominences, that's hydrogen gas, tossed up above the surface of the sun in the sun's magnetic field. And they slowly disappear as the moon moves on. In totality, when the sun's bright photosphere is covered, it looks like a black hole in the sky, surrounded by the sun's beautiful pearly white corona. You can see streamers and polar tufts. They're in the form of the sun's magnetic field. So here we see the sun's appearing as a black hole in the sky, surrounded by the corona. The sky's dark from the moon's shadow, and the great view of the sunset colors, which occur right around the horizon, 360 degrees. It's a surreal and amazing experience, and it often leaves people feeling quite emotional. Now, you can only see this if you're in the path of totality. You must be in the path. Even a 99% partial eclipse, you won't see these effects. So you must be in the path of totality. This is definitely not a case where near enough is good enough. Okay, so where are these eclipses? This is a map of all the total solar eclipses from now until 2038. This is derived from Fred Espinak's EclipseWise site, where there's a whole lot of solar eclipse information. Very good site to go to. What you can see is the remarkable concentration of eclipses around Australia. Out of the 12 total solar eclipses that occur in this period, there were 5 in the Australian area. Now, within any 20-year period, it is very rare for such a concentration to occur in one area. So here are the numbers of total solar eclipses that occur in each continent. Just 1 in North America, none at all in South America, 2 in Europe, and both of those are in Spain, 3 in Africa, 2 in Asia, and the 5 in our region. So we really are fortunate. So here are the 5 paths of the total eclipses in our region. There's the first one, just 1 year away from us, which will occur on the 20th of April 2023, just under 12 months away. The next one, 5 years later, 22nd of July 2028, goes right across the country, comes in from the Kimberley, across Central Australia, New South Wales, and actually goes right across Sydney, and then ends up going across New Zealand. The next one, just 2 years later, is coming in from the Indian Ocean, 25th of November 2030, comes across South Australia and ends in southeast Queensland at sunset. That's the sunset point for that eclipse. The next one, 7 years later, is again a coast-to-coast one that comes in from Western Australia, across Northern Territory, across Queensland, hey, comes across Brisbane, and then goes across New Zealand. And the next one, and the last one in the series, just 1 year later, is 2038, 26th of December. And that again is a coast-to-coast one. Comes across Western Australia, South Australia, down the Victoria-New South Wales border, and across into New Zealand. So most states get a reasonable share of this. 4 in Western Australia, 4 in New South Wales, 3 in South Australia, 3 in Queensland, 2 in Northern Territory, 1 in New South Wales, and 3 in New Zealand. Now, so I'm sorry, Tasmania and ACT, you miss out this time, but there is an eclipse not far away from you. Now, it's often said that everyone must experience at least one total solar eclipse in their lifetime. So here's an opportunity. Every Australian must get to one of these paths of totality, and there's one not far away from everyone. Just a warning, though, they can be addictive. The most common question that you hear right after an eclipse is when and where can I see another? And here's another warning. After these 5 total eclipses, it'll be 28 years until the next one in 2066. And after these 5 eclipses, there are only 4 more in Australia until the end of the century. Okay, now here for the first eclipse, 2023, here's an animation of the moon's shadow as it moves across the Earth. This is taken from the perspective of the moon. It's on these 2 websites. You can get them on these 2 websites, Michael Zeiler's Great American Eclipse and Fred Espinak's EclipseWise.com. And you can see the path across Australia, across Timor-Leste, across Indonesia, and then heading out into the Pacific. Here's the time of the eclipse and the duration, how much time you get of totality. And here's the path as it goes across Australia. Path of totality coming up here past Western Australia, just clipping Northwest Cape and then heading off towards Timor-Leste out here. The green lines on this diagram are the amount of partial eclipse that you'll get. Now, this is the amount of coverage of the sun's diameter by the moon. And of course, the closer you are to the path of totality being here, the greater will be the coverage of the sun's diameter by the moon. You can see here, Broome, 91%, Port Hedland, 95%. Being further away, Perth, 77. Over on the other side, Brisbane, 27. Canberra, 19%. But the important thing is that all Australia gets a partial eclipse at that time. Now here's some details of it, of Northwest Cape area. So the left part shows the path across Western Australia. Here's the centre line and here's the edge of the path. It goes across Northwest Cape, some islands, Barrow Island, and then the Montebello Islands up here. Now, the Montebello Islands are where the British conducted atomic bomb tests in the 1950s. And one way to get there, if you want to, is to take a fishing charter boat out of Karratha. That's further up the coast from here. Now, Barrow Island is completely off limits because it's a Class A nature reserve and it's also a gas processing facility. So there is no tourist access. Now, the islands off the coast of Onslow may provide an opportunity for total eclipse viewing because I understand that the Shire of Ashburton is actively looking at options for boat trips to one or more of these islands out from Onslow. But for most people, the Northwest Cape will be the area to go. It's reasonably easy to get to by road. Here's National Highway 1, it comes up past there, approach from Perth at the south, or coming from the north from Darwin or Broome down the highway, and then the main road that comes into the Exmouth Peninsula. Over on the right-hand side, Northwest Cape. Northwest, on the right-hand side, you can see where the eclipse path is, the centre line here, the edges of the path in red. The area here, it's about 40 kilometres wide from one side of the path to the other. There's about 100 kilometres from here up to here. So there's quite a large area. And the main access road comes in from Manila up into the eclipse zone, passes Learmonth Airport. The centre line, the road goes over the centre line here, and then the town of Exmouth, where there'll be a lot of activity for the eclipse, up past the communication base, and then down on the west coast. So there's reasonable access right around. There's not a great deal of access into the centre. This is the Cape Range National Park. If you can get there, there'll be great viewing opportunities in there. There are some nice canyons in there that might provide some beautiful foreground. So there are many observing locations around here. The ground's generally flat and open, and there's some great observing locations in the national park. And the Shire of Exmouth is likely to set up dedicated observing locations around this zone. Now, of course, accommodation is always a challenge, and with 1 year before the eclipse, almost all the regular accommodation is taken. But additional accommodation is likely to open up in the period leading up to the eclipse. I understand the Shire of Exmouth is working on that. And you may be able to book a camping spot in the national park. There are some fabulous camping spots along the coast here, right along the beach. So now the Western Australian government has just launched their website, ningalooeclipse.com, and there's information there about the eclipse, and there's also the opportunity to link to accommodation options there. Now you might ask, what's the timing for this? Excuse me. So the total eclipse starts at about 11:30 and typically lasts about a minute. It's just over a minute on the centre line here on the road, and a little less at Exmouth and Learmonth Airport, a bit under a minute. So the timing of the eclipse, or how much totality you'll get, depends on how far you are from the centre line. and also where you are along the path of totality. But that's what they, it looks like pretty close to a minute that most locations within here will get. Now, if you want to work out what these timings are, it's pretty easy to do that. There's two ways you can do it. One is with Google Maps, and the other is with Google Earth. With the Google Earth one, you need KMZ files. You can get those from Xavier Jubier's Solar Eclipse Google Earth files. Just search for that and you'll find it. So you open Google Earth, you download the file for the eclipse that you want. You open the file to see the eclipse shown on Google Earth, and it'll come up like this with a blue center line and red lines matching the edge. You locate the red square over the point of interest. You click on the red square and you can see this eclipse data, which shows you timing of the eclipse, all the different phases, altitude and azimuth, where the sun will be in the sky. It's got timing information and other information there as well. And the other way to get that information is from Google Maps, which you'll find on Google on Fred Espinak's eclipsewise.com/solar website. You go to that website, you select the eclipse that you want and select link Google Eclipse Map, and the Google Eclipse Map will come up with the path shown on it. Again, you can click on a spot there and you come up with a data box just like that. Okay, now I hear you ask, what about the weather? What's it going to be like for this eclipse? Well, the place to go for this information is Jay Anderson's eclipsophile.com website. Jay Anderson's a retired meteorologist, and his website is absolutely packed with information on climatology. Now, what's the climate for each of the zones where an eclipse is going to happen? And there's a lot of information about the weather systems in this area and what's likely to happen with this eclipse. But on this chart that he's drawn, you can see here the cloud fraction, cloud percentage. And this is the average daytime cloud amount measured by satellite over the past 20 years for this month, the month of April. You can see down here, cloud percentage is fairly low. That's a good place to be. And then the cloud percentage is increasing as you go up. So blue is good, green, yeah, a bit problematical, but red, you want to stay away from those places. So you can see that this area around here, around the Exmouth Peninsula, and the seas out here are a great spot. Looks like they have the best potential for clear sky observing. Now, as Jay Anderson says, climate is what you expect and weather is what you get. So this is just on average. It's no guarantee of what the weather on the day will be. So you really need to watch for the weather and see what's happening to get a good understanding of how clear a view that you're going to get depending on which site you've chosen. There's also the possibilities of cyclones, of course, but April is at the end of the cyclone season, so hopefully that potential is fairly low. Now, Jay's also drawn it up in a graph here, and you can see very clearly, here's the percentage cloud cover in April, and out in the Indian Ocean, it's not a good place to be. So any tour boats that are going out, ships that are going out in this area to watch the eclipse will have to be fairly careful. Obviously, in the Australian area, that's pretty good. But as the eclipse extends out to East Timor and to Indonesia, again, the cloud prospects are not so good. Okay, so let's move on to the next eclipse, 2028. And here's the animation, thanks to Michael and Fred, of the moon's shadow moving across Australia for the 2028 eclipse. Again, this is the time it occurs, and here is the duration of totality as it goes across the Kimberley, down through central Australia and down past Sydney. So here's the map of Australia that shows the path of totality. Greatest eclipse point is here, and that's where you get the maximum time for the eclipse, maximum duration of the total phase of the eclipse. It goes down through Northern Territory, southwest Queensland, New South Wales, and right across Sydney, and then takes in New Zealand as well. They're a very extensive eclipse, and I was interested looking at the Tona Stevenson's presentation just before this one. She was talking about the 1922 eclipse, and it came right through here as well, and it had a fairly long duration, just like this one. you can see here the maximum duration is 5 minutes and 10 seconds. So a really nice long eclipse. So Tona, there's one for you. Now this one picks up, amazingly, the two Australian territories out here of Cocos and Keeling Islands and Christmas Island. That's fairly early in the morning, and they get almost 4 minutes of totality. Comes down through the Kimberley, right across Mitchell Falls. That's a popular tourist spot. Kununurra. And you can see here that even though the maximum is 5 minutes and 10 seconds, and Kununurra, there's its spot there, is fairly close to the edge, still gets almost 3 minutes of totality. So wherever you're in the path, better to be close to the centre line if you want more totality. And there's Tennant Creek, 3 minutes and 21 seconds. Devil's Marbles. This goes right across Devil's Marbles. So I expect that'll be a really popular spot for photographers. Past Baduri, remember Baduri. Thargomindah, Burke, Siding Springs. The Coonabarabran Observatory is within this path. They get almost 2 minutes. So I know what they'll be doing for this eclipse. Dubbo and right through Sydney and right across New Zealand, with Queenstown being the spot there. And here's the details of the path as it comes across Sydney, down through Dubbo, Wellington, Mudgee, Orange, Bathurst, Lithgow, Penrith, the entire Sydney region. And that extends down to Kiama on the coast and up to Gosford and this central area here. Now, my estimate is there's something like about 6 million people within this zone. So that's a huge population that will be exposed to this eclipse. Just a comment here, the dish unfortunately just misses out. Now yesterday in Steve Russell's talk, he was talking about being fortunate to be in Orange. So with a bit of luck, you'll have some good weather on that day. So just talking about the good weather, here's Jay Anderson's map for July. And the path of the 2028 eclipse going through. Now, July is obviously a good time for northern Australia. And you can see here that blue is good, green is problematic, and red you want to stay right away from. We've got some pretty good places. Central Australia looks pretty good. Up in the Kimberley looks excellent. And maybe down here, Steve, you might have to think about maybe travelling up a little. Now, when you're looking at where to go for an eclipse, it's a good idea if you can pick a spot where there's a road within this pathway, so that if you have to move on eclipse day, you're able to find a spot that's maybe a little clearer than the one that you've actually chosen. Now, the next eclipse is in 2030. So that's only 2 years gap until this next one. It comes up from the Indian Ocean across South Australia and winds up at the sunset point in southeast Queensland. This is where the eclipse finishes at sunset. And it comes close to Brisbane, so it's getting closer to me. And again, this shows the amount of partial eclipse that you get. The closer you are to the path of totality, the more of the sun's diameter will be covered by the moon. Adelaide, 92%, Alice Springs, 76%, Darwin, 41%, and all the way down here. But the important thing is, again, that the entirety of Australia gets a partial solar eclipse for here. Now, this path might look familiar to you, and that might be because you went to the 2002 eclipse in South Australia. That went through Ceduna, which is right here. Now, Ceduna misses out this time, so it's just outside the path. But those places that are in the path of totality, those lucky spots, Streaky Bay gets almost 2 minutes of totality. The Stewart Highway crosses there. Wilpena Pound, Tibooburra, Cunnamulla, Surat, and Miles. And only about 200 kilometres from Brisbane. So that's fantastic. It's coming closer. So Jay Anderson's weather climatology statistics for here. Again, blue is good. So pretty good statistic here. It's probably around about the 40% chance of cloud. So that's one that you might have to think about moving on eclipse day, depending on what the local weather is and whether you're going to get clear skies in the spot that you've chosen. Okay, so the next eclipse is 7 years on in 2037, 13th of July, 2037. Now, again, it's a coast-to-coast one. Comes through Western Australia, Northern Territory, right through Queensland, and goes right through Brisbane. Brisbane gets a total eclipse. And then, of course, goes across New Zealand. Greatest eclipse point is here. Now, poor old Alice Springs gets a 99.97% eclipse. They are so close, but remember my advice, that near enough is not good enough. They need to travel 5 or 10 kilometres to get into the path so that they can see the total eclipse as well. And the same thing as before, the whole of Australia gets a partial solar eclipse. And the closer you are to it, the greater percentage of the sun's diameter covered. Further away, Hobart, 71%, but the whole of Australia gets a partial eclipse. And here are the lucky towns that are in the path of totality. Geraldton. Who remembers Geraldton from the, 1999 annular eclipse? That was a popular spot to be at. Mount Magnet, Uluna, Yulara. So Ayers Rock and the Alders, right in the path of totality. The greatest eclipse spot is right here. And right beside Bedourie. Remember Bedourie? It had a previous eclipse through here as well. Windora, Charleville, Roma, Toowoomba, Warwick, Brisbane, Gold Coast, Byron Bay. So all these places around here are going to get that. But again, the whole of Australia getting a partial eclipse. Now here is the an overlay of the 2 eclipses in southeast Queensland. Here's the one, 25th of November 2030. You can see coming up to the sunset point here, 200 kilometres from Brisbane. And here's the 13th of July 2037 one, which comes down through Charleville, Mitchell, Roma, Miles, Dalby, Toowoomba, Warwick, Stanthorpe, Brisbane, Gold Coast, Byron Bay. Now, just might point out, here's a fantastic road if you need to move on eclipse day to find better weather. And just point out here, Surat and Miles are the lucky ones. They get the prize for being in the as the 2 places that get to see both eclipses. Now, I said Brisbane, it's 200 kilometres away. This one, I live right about here, which happens to be about 25 kilometres from the edge of the path. I might think about moving between now and then. And here's Jay Anderson's climate statistics for July again. Again, blue is good, so pretty good shape for this one here. It's 20 to 30% looks like. Central Australia looks really good if you're heading out there. So good, reasonably good prospects for weather then. Now the last one in the series is the 26th of December 2038. The path of totality again goes coast to coast, Western Australia, South Australia, down the Victoria-New South Wales border, and then across New Zealand. Again, the closer you are to the path, the more of the sun's diameter will be covered. Canberra, 95%, Darwin, 54%. But the lucky towns here are Onslow. Remember Onslow from 2023 and the islands off the coast here? Tom Price, Whyalla, Port Pirie, Renmark, Swan Hill, Shepparton, Bright, goes right through Malakuta, and then Palmerston North gets the eclipse over in New Zealand. Greatest eclipse point here is 2 minutes and 18 seconds. So virtually all these places on here will get around about 2 minutes of totality. And again, you can see the whole country gets a partial solar eclipse. Here's Jay Anderson's climate statistics for this in terms of across Australia. Again, sort of blue is good, so northwest will be pretty good. Down here, you might have to be a bit careful on eclipse day in terms of where you pick to observe from. So here are the 5 eclipses. The 5 solar eclipses that go across Australia. So, and here's your opportunity. Everybody in Australia has got the opportunity to get to one of those. So just a few tips on solar eclipse photography. It really depends on what you want to image. If you want a landscape image with the eclipse in that scene, pretty much anything will do. Even a smartphone, a point-and-shoot camera, a DSLR with a wide-angle lens will shoot that. You get a pretty reasonable photo. Now, there's a great range of exposures through these. So if you want a photo that encompasses them all properly, you'll need to do multiple exposures and then do some high dynamic range work afterwards to fix that. If you want something in detail, the partial phases, the Bailey speeds, you will need something like a DSLR and a long lens, at least something in the 300 or 1,000 millimeter lens length. For exposures, I can't go past just recommending MrEclipse.com. That's a site which is dedicated to eclipse photography, run by Fred Espenak, and does a great job of telling you everything you need to know about eclipse photography. For equipment, you need, of course, a camera. You might think about a tracking mount if you're doing a time lapse of the eclipse. Timing is critical, particularly for the eclipse next year. 2023, it's only about a minute or a little less, so you need to be on the ball for that one. You need to have your camera ready. You need to know what exposures you're going to use, and if you want to do some serious photography, you probably want to think about camera control for taking your photos. There are two very good programs for this. There's Eclipse Orchestrator that works with PCs, and Eclipse Maestro that works with Macs. You might need to do some processing afterwards, particularly if you want to do some high dynamic range imaging. And of course, eye safety is really important. You need to have filters on your optical instruments for the partial phases. Now, if you think about a landscape image, it's nice to put something in the foreground. So here's a simulation that I brewed up for what it might like to look like in Sydney. And this might well be a pretty popular spot to take a photo. And it's pretty easy to put an image like this together. This is a simulation I've done. You work out where the sun is going to be in the sky, and then position yourself such that you're that the image is in the foreground. It's pretty easy to do that. Just bring up the data in Google Earth or Google Maps. If you position yourself from here, you'll find out what the azimuth for the eclipse is. In this case, 328 degrees. So using Google Earth, you can draw out using the ruler to find what that orientation is at 328 degrees. And then you just need the elevation to get the sun in the right spot. A really good idea is to go there the day before, have a look at where the sun's going to be. It won't move much from one day to the next, and pick out your spot. And like I say, I think this might be a pretty popular spot. Now, this might be a bit of a cartoon, but this is a serious issue. Oops, and oh, come on. Safe solar viewing. Now, talks like this always come with a warning. Never look at the bright surface of the sun without special purpose solar filters, such as certified eclipse glasses. Now, the previous official advice in Australia on safe eclipse viewing has had a bit of a checkered past. For the 1976 and 2002 total solar eclipse, the official advice was lock your children indoors and watch the eclipse on TV. There were even moves to fine anyone selling eclipse glasses. Now, the reasoning then was that there was no Australian standard for eclipse glasses to guarantee their safety. Now, for the 2012 eclipse in Queensland, there was a different approach, with recognising that people would watch the eclipse and would use eclipse glasses. And what was needed was advice on what standards the eclipse glasses should comply with, and advice on how to properly and safely use them. And the Queensland government issued advice to that effect. Now there's good news with the international standard being adopted for eclipse glasses, and that standard has been adopted in Australia. Now, for the 2017 eclipse across the USA, the American Astronomical Society took a similar approach, issuing advice, issuing this advice over here, saying that the eclipse glasses should comply with the international standards, and they provided good advice on how to use them safely. And more importantly, it was endorsed by IAS, NASA, the National Science Foundation, and endorsed by professional eye care groups as well. And the outcome in terms of extensive public viewing for that eclipse and very limited reported eye damage was very good. So I think it's an appropriate approach for Australian authorities and organisations to follow here. Now, if you're planning on using optical equipment at the eclipse, telescope, binoculars, or a camera, You must use a safe solar filter for the partial phases, but don't forget to remove it for totality. Lots of people have forgotten that. And of course, it is safe to view totality, but of course, you must be in the path of totality and immediately use a filter as soon as the bright surface of the sun returns. Now, projection can be used for the partial phases. There are various methods: pinhole, telescope, mirror, sun funnel. Some of those are better than others. But I can't go past recommending the AAS website, eclipse.aas.org/iSafety. It's got the latest advice there, and it's all sorts of good information about how to safely view an eclipse. Now, the last thing I want to talk about is education opportunities. Here, there is a huge opportunity to use this dramatic natural event to stimulate an interest in young people for science and technology. In 2012, the Astronomical Association of Queensland and Science Teachers Association of Queensland cooperated to develop eclipse material on eclipse science and education, and including classroom activities. They put together a booklet and sent those activities in the booklet out to all schools in Queensland. And that was a pretty successful program to stimulate people with an interest in science. We had a website, eclipse.aaq.org.au. That Eclipse website is still there. You can go there and download the booklet or the classroom activities if you want. It's currently been updated and will include information on the 5 eclipses that we're talking about here, including most of the diagrams that you're seeing. Now, here's the opportunity for all amateur astronomers and societies to engage with the public, to encourage the public to go out and experience the eclipse, provide information on eclipse science, safe solar viewing advice. And it's vitally important for the 2028 eclipse. There'll be a large population there who will need this information. So there's an opportunity to partner with libraries, museums, science teachers, schools, scout and guide groups, etc., all sorts of groups to get that information out to the public. That's really important. Now, I'll put my email down here. That's eclipse@aaq.org.au. Feel free to email me if you want any information or any advice as to how to go about this, or have got any good thoughts on how to progress it. So my last slide is just simply a listing of all the links that I've been talking about throughout this talk. So you might like to have a print screen of this. Whack that button now, or alternatively come back here, have a look at those, and have a look through those websites. So now I think we can probably, Mark, open it up to questions.
We can. We've got one question from our previous presenter. Tono wants to know what the best filter for a DSLR camera for a partial eclipse phase might be.
Sorry, say that again, please.
Yeah, what the best filter for a digital SLR camera for a partial eclipse phase might be.
Okay, well, most people make up a filter themselves. You can buy solar filter material. There are two filter strengths that you can buy. One is ND 3.8 and the other is ND 5. ND 5 means it's 100,000 to 1 reduction. So you do need that amount of reduction. And there are lots of online instructions for how to make solar filters to go on the front of your DSLR, either on your lens. You can also make up filters that way to go on your telescope or binoculars or any other. There are some commercial ones that you buy. There aren't very many of those. One website I'd recommend, website that I'd recommend is Joe Carley's website. It's got some nice information on how to make up solar filters for digital cameras.
Now, no other questions. A lot of people loved your presentation. So a lot of
cool. Well, I enjoyed giving it.
A lot of thanks, Terry. Awesome talk, Terry. Brilliant presentation. So everyone really enjoyed it, and I did as well. I love the enthusiasm. What I might get you to do, Terry, is email me all of those links there, and I'll actually put them in the description of the ASVs and the NACAA YouTube channel in the description of this particular stream, so that everybody can just click straight through to those websites. That'll make it a lot easier for everybody.
Okay, that sounds fine. And
thank you very much.
really encourage everybody to take the opportunity. You don't get this, it only comes once in a lifetime. So get out there and watch one of those eclipses. You've got plenty to choose from.
So thank you for your presentation today, Terry. It was wonderful, very informative, very educational, which is what we like to see as well. Now, thank you everybody for joining us for our second stream of today. Our next stream will kick off at 1:30, gives some of us some time to go and grab a bite to eat. So we'll see you back here at 1:30 for two more talks, one on smart telescopes and one on basic meteorology for an observing and astrophotography session. Also, please remember that we still do have Easter NACAA raffle tickets available. That will be drawn at 5:30 this afternoon. Head to our website, www.asv.org.au, and the link is on the website, $5 per ticket, with all the funds going to our new project, which is ASV's remote observatory project for STEM education. We hope you enjoyed the stream because we're certainly enjoying bringing these to you. We'll see you all back here in about just over an hour's time.